All right. Good morning and happy Saturday. It looks like we got sound to OBS at least. Don't need this one open anymore. Good morning to DJ Devin and C. Grover. I had the deep dive card up. As a reminder, I will do a deep dive this upcoming week. I guess it's not this week yet, but this upcoming Friday I'll be on deep dive instead of Scott. Scott's got something else going on. So good morning to everyone. Hello for anybody that might be new. My name is Tim. I go by Foamy Guy on GitHub and Discord. Generally speaking, I work on CircuitPython related stuff, although occasionally we venture outside of those bounds into other programming stuff. If you are brand new and don't know anything about CircuitPython, you can learn more at circuitpython.org, which is the main website for the project right here. This is basically a version of Python that is designed to run on tiny computers called microcontrollers. In this case, I have a Feather ESP32S2 TFT, and the main microcontroller, the main chip, in this case happens to be underneath this metal bit here, but there's, effectively a whole computer inside of here. It has a little bit of storage, it has some RAM, it has a CPU. It's able to run programs. In our case, the programs we're running on it are made with Python code, thanks to CircuitPython running on that device. So that's kind of the high-level look at what's going on here. Excuse me. On circuitpython.org, if you click downloads right there, you'll be able to see a list of the currently 430 devices that support CircuitPython. Again, the one that I'm using right now is a Feather S2. We're going to go with actually TFT, I think is the best way to search these ones up. It's a Feather S2 TFT, this one right here. But there are lots of these different microcontroller devices that support CircuitPython. They do come in all different shapes and sizes, and the specific thing that I'm going to do with it today is obviously not the only thing you can do with it. Many of these devices come with what they call, I/O pins or connectors that allow you to connect other devices, such as sensors or lights or speakers or buzzers or beepers or buttons or levers or knobs or any kind of little electronical widget that you can imagine. You can typically connect to these microcontrollers, and then if you're using CircuitPython, you can use Python code to interact with that other widget. Today's other widget for me specifically is this right here. If I can get it going the right way. ADT7410 temperature sensor. This one happens to have stemma connection cables, or stemma QT, which are these little plugs here on the end. You can see I have a wire plugged into one. That's the other end of the wire, and we're going to be plugging that into the socket right there in order to connect it. To round it out and get us going for the day, let me also just say thank you to Adafruit. Adafruit is a hardware and software company based out of New York. They design and manufacture the microcontroller devices, like this device right here is designed and manufactured by Adafruit, as is the sensor right here. You can purchase hardware on their website at adafruit.com. They are the company that is providing the financial backing for the CircuitPython project. So they're paying the folks who work on the project. There's a team of folks who work on the project full-time, and there are some folks like me who work on the project part-time who are paid to do so by Adafruit. So thank you to them, and head over to adafruit.com if you want to get yourself some goodies, be it microcontrollers or sensors or other things that you can hook up to microcontrollers. All kinds of good stuff there. Also, the Learn Guide, the Learn system, I should say, is great if you are not looking for hardware, but instead just looking for projects to do or looking for documentation on hardware. This is great as well, which is also an Adafruit, not really a product since you don't buy it, but Adafruit, I guess, service. It would be a site that they provide. We want the ADT7410 I want the main one. You know, really what I'm going to do, what's best, I find, or easiest for me, is to just search up the product first, which is this, and then the Learn Guide is linked usually right down here. The main Learn Guide for the product, for the hardware. So this will be the main sort of everything about this hardware, the pinout. If there are ever revisions, they'll be listed here to tell you to figure out, you know, help you figure out which one you have, all of that kind of stuff. This is a temperature sensor. There is a PR in Hug Reports, and thank you to Jose David, who has done a bunch of great things in CircuitPython over the years. They've made this PR to rewrite the library to use the register, which is another library, just a different way of writing low-level I2C driver libraries. So they've rewritten the library to use that, add more examples, operation mode. Not sure what that does. We'll have to look into that bit some, and improve the documentation. Tested it on an old 7410 without the stemma connector. So we have a newer revision, a new one with this stemma connector, so that's how we'll test it. Ordinarily, if you were sitting down to do this, you need to like figure out, that must be the older one there. You would need to figure out how to wire it up. It's I2C, so it's not too bad. SDA, SCL, you know, 2 wires and then ground and power. But in our case, we also just have the stemma, so we don't have to worry about that. Really what we want is in this page, which will have not only the wiring, which we just talked about, and it's super easy, but the code for running it is right here. I do not even have PyCharm open. Okay. Let me shuffle some windows around while that's going on. How's it going, Johnny? Nice to see you needed the company. My very first Arduino library was actually for a temperature sensor. Nice. Nice. Yeah, temperature sensor is something I have not messed too much with personally. But it's fun to see. I definitely will say it's fun to see kind of like real world measurement of something that you know care about. Like humans tend to care about the temperature once it gets outside of a certain range. And so it's interesting to be able to see temperature inside, temperature outside. I'd love to have a little like base station set up where I could see both temperature inside and outside somewhere together. Maybe I should work on that. All right, well, that's the wrong project. Let's go to device workspace. One moment here. Hey, big, thank you. Let's go to this device workspace, this window. Bring this back, get big again. What's this? I guess we'll need to plug in the device. Let me point out what I have on here as well, if folks are interested. I have on here a simple test that I submitted. If anyone is willing to try it out or has ideas about what would make a good, like what would make good stuff to put inside device simple tests, this PR, which is what 8457 is open, which is this code that's running on this thing right here. As a simple test for the ESP32S2 Feather, I have made it make a HTTP GET request to the Adafruit test URL and then populate the response into a label that's been put on the display with display.io. The other thing, which is a little harder to see probably because of the way my lighting is set up, the NeoPixel right there is cycling through a rainbow. And then the regular LED right there, which is red, is blinking on and off, just blinking over and over again. And then when you press the button, which is very small, but right here, then the regular LED will stay on. So now it's just solid red right there. If I release the button, it'll go back to blinking. Not too much, but it's enough to hopefully show kind of the main features of this device, which in my mind are the display, the internet, the NeoPixel. Honestly, the blinking LED and the button I would not call major features of the device, but I do think it's good for the simple test because they're two basic actions that a lot of folks who are just working with a device for the first time might want to do. But for this stuff that we're working on today, I'll plug in the stemma carefully. Let me catch up on the chat also. I don't have any ADT sensors, so we need to see how it works. Yeah, I was surprised at the cost on this thing is only like, what was it, $7 or something on the main site there? I was surprised how cheap it is. I don't know anything really about the actual sensor though. Where's the yeah, $6. Seems like a neat little thing. You know, it's one thing I do find interesting. A lot of those temperature sensors, they'll have like the cutout in the board or whatever, right? This one's just in the chip mounted straight on there, which is interesting. I guess it's got better kind of like ambient temperature control or something like that. Or just takes it into account better. I don't know. I don't know anything about this. What does it say pace for? That's weird. Oh, okay, it's the end of workspace. Fair enough. I mean, it's still weird, but it makes a little bit of sense. All right, let me save this one off. Code ESP32S2 simple test. To start with, I'm going to take the temperature sensor simple test from the guide, which I just clicked out of, didn't I? Should have new tabbed that one. Okay, here we go. Okay, I didn't actually catch up on the chat either, sorry. No. Home Assistant, I have an ESP32 with sensors on the outside temperature is measured with one of the one-wire sensors. Nice, okay, so you got a graph going as well, which would be a nice touch as well. How can I ask, how long is your graph over? Is that like 1 hour or like 6 hours or a full day or something? Curious, what's the window that that you've got that on? Love to go outside. Love to get an outside temp sensor with solar and LoRa. Oh, that'd be cool. Power of solar too. Yeah. Summer is over. Yeah, it's getting to. It's definitely looking like summer's over around here as well. Use ESP Home, even easier than CircuitPython. You just write some YAML instead of code. Oh, nice. Okay, so it's got like a pre-built thing. You kind of configure, give it a configuration file, and it does its own stuff. It's already pre-programmed how to go. How to do it stuff. That's cool. That's really accurate. Plus or minus 0.4 C. Wow. If it's between 40 and 105, or it goes between 40 and 105. Or by far is BME, like 4 of them. Yeah. BME 280. I think is that one built into something? BME. I've used a. I always get it confused, honestly. There's BME 280. There's like a BME 680, I think, and I don't. I've used possibly even both. I'm not sure. But I always get them confused. If I'm looking for one or thinking about one, I always end up crossing wires. Oh, it's 24. Okay, so you get the graph for 1 day. Nice. ESP Home is code generates the firmware, then it uses Platform I/O to compile it. Oh, okay, that's neat. You feed it configuration, and then it builds you a firmware in the cloud, which you'll then download and run onto your device. So do you it downloads a what, like a bin file or a UF2 or something like that when you once it gets compiled inside there? The 280 is the one on some feathers. Okay. All right, CodePy we can overwrite because I copied off this. Oh, I actually named it wrong without the TFT, but I have a different copy. Let me also just duplicate that over. Although the one without the TFT, you would want a different simple test because you would not do any display IO stuff on the other one, right? All right, let's make sure this works just normal. I mean, probably we don't have the library installed, so it should just crash with import error. That's my guess. Unless I installed it before. No, incompatible. Okay, so it has a library, but the library is incompatible. What am I? Okay, so I'm on like main-ish from probably, I don't know, a little while ago. Within the last week or two, probably. Yeah, let's just delete the library and then install the... Oh, wait, what? Wait, what? Oh. Okay, we have the Python one, but the Python one must use register. Maybe, do I have the PR one already? I might have the PR one already. Maybe, yeah, I think so, actually. Either way, we're gonna grab a fresh copy, but what failed here? We do need to figure that out. So register, is that, okay, those are MPYs. We'll need to probably just nuke that. Bus device? I think it's in the core now, so I don't think that matters. Yeah. I'm gonna delete this one that I have just because I have no idea what when it's from or anything, if it's the PR or something different or whatever. Do I have ADT locally? Not in the cloud, but you got it. Oh, okay. Built locally. First time you need to upload the code over serial, and then it's all over the air updates. Nowadays, you do it in the browser. Oh, okay, so platform IO, or there's no M there, I guess. Platform IO. Does it compiles with JavaScript then on the client side, and then you can upload it from there as well if you have like USB serial or whatever turned on. I do have the local one here. New window. We're on main. Git remote. Git fetch. GHPR list. Checkout 24. Checkolot. Checkout 24. Copy. Tag we don't need open. Device. Paste. And yep. And then we need to get register and bus device, but well, we need to get register. I don't think we need bus device really, but we do want the Python version of register. I'm gonna go circuit install Adafruit register --py. Oh. I think, yeah. I think I saw about this actually in the Discord. This is another thing we could look into today, potentially, or soon, definitely. Circuit, I think if we do upgrade, maybe this can fix, or... The CircuitPython org bundle. Although that's a... I don't know, that downloaded. I don't know, I think we just needed to update Circuit. It did install bus device and register. I'm pretty sure we can get away with actually out. I'm gonna try though. I'm gonna try. I don't think we need those, right? Because it's in the core now. Isn't that something Mark Gambler did a while ago? ADT. So now, oops, so we have ADT, we have register, it's Python code, not MPY. Okay. No device. Just have a different, there's a jumper thing. Maybe there's like different addresses or. It's not like the stemma QT is not like directional, is it? There's not like one in, one out or anything? You can go either side, can't you? I mean, I do have it as the opposite side as this photo. I think that part doesn't matter though. Let's say 48 right here, and I'm guessing you can jumper these things in order to change the address. Yeah. 48. Oh, you know what? I think this is the wrong I2C bus. Wouldn't it be stemma? No. Import board, dir board. We do have stemma I2C. I'm pretty sure that would be the one we need. Is this powered? There is a power LED and the power LED is on. You know what? Are these like jumped? Hold on. Oh, wow. Catch up on the chat. To get this to sit upside down, it's really not gonna play ball. Mr. Lego Robot can help? Nope, not really. Another beanbag, I guess. Brother's giving me his Pi 4 he's never going to use. Maybe I'll put some Home Assistant on it. First I've heard of ESP Home. Here you go, connect your local USB serial port and upload the bin file. Nice. So let's build a bin file. Combination of workshop, interior, sensors, and local open weather map org weather data on AIO dashboard showing a 3-day trend. Oh wow, yeah, that's really slick. Yeah, I do like the idea of kind of a personalized weather dashboard. I mean, some weather sites are alright, but lots of weather sites have lots of weird ads and just like is not organized in a way that's primarily suited to an individual. I mean, you can put your zip code or whatever and it's pointed to you, but like intermixing with your own sensors at your house or in places you care about is very cool. And being able to line it up next to other graphs and things you care about over time is super neat as well. I wonder if you could add a map. Does Adafruit.io have like iframes or something on their dashboards? Can you load in some other page? My office sensors even have a radiation sensor. Oh, nice. Yeah, that's a good idea. Okay, there is a stemma I2C. We still did not find it. I mean, did it run though? Yeah. Okay, let's run an I2C scan and see if we find anything. Let's start there. Oh, the other thing I was gonna do is try to look at this. I mean, I will say See how much better we can zoom that. I don't know, we might be getting a bit too close. It's not a microscope. Where did my zoomer go? Oh, there it is. I didn't do anything. Oh. Wait, what? That's all we got. That's about right there, okay. So those don't look jumped there. I mean, the very, like, middle, like, centered vertically on these two things, you can see that little thing there, right? There's, like, something there. It almost looks like those are jumped together. Like, hold on, let me also just, I'm going to unplug this too. That way we'll get a fresh unplug, replug. Maybe we'll swap cables. Oh, you know what? Yeah, this is, it's not seated very well on this end. Okay, that's probably it. I'm gonna get a better look at these jumpers, though, with some light. Okay. Yeah. You know what it is? There's a trace, actually, under... There's a trace under the white silkscreen line. That does actually jump those two center pads together. Those two pads are jumped by a trace that runs between them in the middle there. So, which is, I guess, probably ground. Like, you're probably jumping A1 or A0 to ground, I guess. Okay. Yeah. That totally was not seated all the way at all in this thing. Online data is never accurate. Yeah, air quality is a good one. I have, my phone has an air quality sensor which will buzz if I'm in a place with bad air quality, and it's kind of fascinating to see what places you don't think about that are like that. How's it going, Paul SK? Good morning. Nice to see you, my friend. Air quality and radiation, yep. Yeah, I don't know. I mean, a lot of my projects look like that. I'm a very functional, like, it's tough for me to, it depends on the project, honestly. Sometimes I take it overboard and we'll just iterate over and over and over again, even past the point of being necessary. But a lot of times my projects kind of end in the state that one's looking like for you. Okay, let's see if we got this now on 48. Guessing we will. Yeah, there we go. Okay, and I do think we would have not gotten it with this, right? So we did need this changed too, I'm pretty sure. Oh, maybe not. Really? Interesting. I guess that's a different device then. I'm pretty sure, I mean, there definitely are some devices where those are different buses. I thought. Maybe I'm wrong. I'm gonna get scooted up a little bit. Let's see. Blocked by the carpet here. There we go. I don't know if my finger is hotter or colder. Let's see. Colder. Put it down some. Not by too much though. I could touch my cold coffee cup here. And then drop it even farther. I could maybe touch this thing with the cup, or I can get it that close. Boy, it really likes its fives. 125, 725. or rather 175, 375, 125, 875, 625, 375. It really likes its fives. Fives are pretty cool though. I don't know. Black enclosure to the left was my try to make neat. To make neat stuff. Turns out it was a bad idea. Putting a temperature sensor in an enclosure with an ESP32. It's active all the time. Shows temperature of +4 or higher. Yeah, yeah. With temperature sensors in particular, for sure the casing is a tricky business because, yeah, like you noted, it's gonna, if it's enclosed in there, the microcontroller is gonna want to probably run hot unless you have super special microcontroller or you have like heatsink action going on. Even the heatsink is not really going to work though, right? Because you're heat sinking to the air, so heatsink is just trying to get heat off the CPU, but like you're putting it into the case that your sensor is inside of. You almost need like some kind of pass-through situation where your temperature sensor can sit in like an outer compartment or something that's like insulated from the main compartment, but not insulated from the outside too much, because I mean you want some insulation because the outside is like harsh. Okay, so we want the PR. I do have the PR one. Oh, you know what? I guess I actually did. I actually did paste the PR one, so we're actually already. I think we're already using the new one. Which I meant to run the real one first. Honest. Okay, so 23.5-ish without touching it or doing anything. Let me run the real one first. Well, not first, obviously, because I already ran this one. Let me run the real one, though. You know what I wish I had in PyCharm was a rename without refactor. Maybe you can like just uncheck the box or something, I guess. I don't know. But I wish it was easier to do, truthfully. I want a different action for it that's different than whatever it exists today, because I don't do it correctly, and then refactoring has wrecked me a few times. This is the PR version. We want ADT 7410 circa install Adafruit ADT 7410 Pi. Had a similar issue with the workshop's dust-proof enclosure. Although the temp sensor is external, the ESP32 plus the display get pretty hot. Shutting down the TFT backlight when it's not in use made a big difference. Oh yeah, there you go. Turn off the backlight on the display. Yeah, some kind of wake up or something if you touch it or something like that, maybe. Okay, now we have stock ADT 7410, the current one, the old one, however you want to think about it. You know what is interesting? Right away, I do notice that we are not nearly as tied to the fives, right? Like almost our resolution got... I mean, I guess I can't really say the resolution got worse or lower. Wow, this froze actually. Hold on. Oh, I'm not scrolled. Okay. Because I don't know that the resolution is actually lower, but it does not seem as stuck on fives. It is. I mean, it is around 23.5-ish though. I mean, like, I touched it here and got it down a bit further. Actually started just a tad warmer, but and that's kind of the room temp. It was still probably coming back up from when I touched it last time. My cold finger in the cup. So the resolution, I mean, the decimals at least do seem to be different. Let's take a look in the code as well. Those numbers are all 16ths. Oh, the fives, the 125 and the 875 and all that stuff. Okay, yeah. I was thinking it was a common fraction, but I definitely did not know the which one. I do remember that pattern, just not like what what it went with. Let's see, also putting the ESP to sleep helps a lot. Okay, that's a good idea. Nice clear case there, I like that. Gesture detector with light sensor as a wake up. Gesture detector, nice. LCAR's GUI. Okay, and some of this code will be a little bit over my head, truthfully, because I still have not quite delved into the world of like these higher level I2C libraries. I mean, like the communication is low level, but the library is implementing it and giving you a high level interface is really what I mean. So we have continuous, one-shot, SPS, and shutdown. Oh. Maybe the default for this changed. How do we set it? Okay, let's keep reading. Alert status. Alert status? Oh, is this one of those sensors where you can give it a temperature and then it will like give you a callback when it goes above or below? Maybe it has that kind of thing going on. Okay. Unary struct. Yeah, there was a temp over high, temp under low. I think that must be a some kind of callback thing going on where you set a range or whatever, and it will tell you. Like it will send you a signal that says like, hey, we passed the whatever thing, and then if you want to, you could set up your code to respond to that in various ways. Okay, operation mode. Most recent converted result. Oh, interesting. That's cool. I like that you can choose between these. So like one-shot mode, it will like wake up, take one, and go to sleep. Continuous mode, it just takes them and you get the most recent one. That's cool. One measurement per second. The conversion takes only 60 milliseconds. Wow, that's fast. And it remains in the idle state for the remaining 940 milliseconds. Why do they call it SPS? What does that stand for? What does that stand for? And no, that can't be right. Hey, whoa, I'm trying to type here, buddy. Jeez. Also, running some bias adjusting code can be helpful if you compare the temp to a known good. Find the slight discrepancies. Yeah, try to adjust for the difference in code. Yeah, I totally agree there as well. Yeah, so this links to another ADT 7310. This must be sort of related at least, but are we going to find definition of the acronym? Hey, don't grab my foot, buddy. Restless here. Octopus here for a minute. Look like it. Won't chase this too long. Doesn't really matter, I guess. One-shot mode, SPS mode, shutdown mode. It's weird. That's the only one with an acronym. Mode polarization. Maybe it's polarization. something sensor polarizations snap. I don't know. It doesn't matter. Yes, it means sample per second. Okay, fair enough. Very descriptive then in that case. Let's see here. That's not what we did. Thank you, by the way. Okay, so let's keep reading the differences in the code, and I'm guessing that maybe the 5s are in low precision mode or whatever. Resolution mode, and then the non-5s are in the higher resolution. That's my guess, but we'll keep reading. We have a lot of little bits and urinary structs, I2C device. Okay, I was gonna say that's not the address, but this is not address, this is device ID. Operation mode, okay. Shutdown mode can be placed in shutdown mode. The entire IC is shut down. No further conversions are initiated until the ADT is taken out of shutdown mode. Conversion result from the last conversion can still be read from that device even when it's in shutdown mode. The part is taken out of shutdown mode, the internal clock is started, and the conversion is initiated. What does conversion mean in this case? Conversion of something to temperature? Is it like ultimately an analog in or something? It's converting the some kind of input to temperature? Oh, this says high resolution true. Maybe it's not set that way anymore as operation mode, but that's continuous one shot per second. What was it? Cents per second? Sample per second. Work on the bias adjustments impressive. It was there, didn't put much importance until after your efforts. Nice. Tyeth helped with it. Write it with OpenAI. Don't want any attribution for it. So we can do resolution mode. Okay, resolution mode, we need to set that to either high resolution or low resolution. So, yeah. Well, one thing we should be doing too is looking at the simple test from the repo, because it should work with the new one. Did they change? Simple test did not actually. There's resolution mode and operation mode and temp limits. Okay, maybe I think probably simple test should change too, if I'm understanding right. We'll keep reading and see. So resolution mode is a property setter. If it's not in the valid values, raise an error. Otherwise, set it to the new value. Alert status. The current triggered status of high-low alerts as an alert status name tuple with attributes triggered. Sample code, nice. Definitely dig in the docs update and stuff, like these tables and stuff. This is all really nice documentation for this thing for sure. Alert status, that's where we were. Okay, yeah. Configuration's gone, reset, read register, write register. And that's because We extend? Is that right? No, no extend. Okay. Maybe they're just somewhere else. Comparator mode. I don't know what that does. That's interesting. Comparator. High temperature property. High temperature limit. So that's the limit range thingy. That's overall limits. Low temperature, same thing, but on the low side. Critical temperature. Okay, it has two high temperatures. One's critical. Maybe you can do it low or high. I'm not sure. Above. Has two high temperatures. It is all still the same concept, though. You're setting these things, and then it can kind of like alert you when it goes above or below. Hysteresis temperature. I don't know what that means. Examples is updated resolution mode, limits, operation mode, renew settings. Resolution mode, it says, oh, that's one way. Okay, that's a good way to illustrate it, actually. That's just going through the possible ones, just looping over the possible modes. So this will do some, it will do 10, in fact, 10 high, then 10 low, then 10 high. Or do they call it medium? Got the Starbucks name going on there. At least they don't call it grande, I guess, right? No, they call it low. Okay, nice. Okay. So, yeah, let's test this theory. Let's go back to the PR build of the library by, I could just change this, right? Oh, well, kind of. Oh my goodness. This cat is running back and forth up and down the stairs as fast as he can. Okay, so we go back to the PR version. What did I just... Oh, I control clicked. Okay, yeah. That's... Back to the PR version. We don't have those 5s anymore, though. Oh, because it's probably stuck... it's probably still in that mode. It's probably still in high resolution mode. Till I reset? That's my guess. I'm just gonna reset the microcontroller, which should reset the temperature sensor also. Freak out PyCharm while it's happening, so that's cool too. There we go. Yeah, see. I think it's low resolution by default, but because we had the old version of the library set the mode to high resolution, and then I switched to the new version of the code, which was trying to set it to high resolution, but failing because the API changed, but it was already still in high resolution. But when it comes up from cold, you take the power away and reset it all the way, then it defaults to low resolution. This is trying to set it, but the API changed, so it's not working. Did we run across where the API changed, though? Why does that no longer work anymore? Is this high resolution? Buddy, please stop running around as fast as you can, my dude. Resolution mode. So this is new stuff. Status. Temperature. Okay, so it used to be high resolution is a RW bit. which I think means you can set its value and it will get sent onto the I2C bus. And because it's not doing that anymore, it means that this code doesn't do anything anymore. Well, it's not it doesn't do anything, but it doesn't do what it used to do. It doesn't send anything on the bus. Instead, what it does now is just create a property on this ATT object that's equal to true with that name. Because there's not one of these anymore. Resolution mode right there, that is what's configured to that. However, let's say 1, I guess that's a number of bits. Okay, because that's using bits with an S, but then it's declaring 1 bit, whereas this was using bit with no S. Interesting. You know what I want to do is use I2C from the peripheral side, is that right? I wish I could make a microcontroller act as a sensor for another microcontroller to interact with. Because I'd love to be able to control like what registers are inside the I2C bus to explore how these things work. Because I feel like if I could set my own values in there, it would be easier for me to grok what's really going on. Whereas all the existing sensors, it's like it's just set up to where, you know, this location is equal to this meaning. I don't know, but I could feel like I could paint a better picture in my mind. So theoretically, you could set this to well, you can't really set it to true though, can you? I don't know. The new way though, the new way to do it is setting operation mode right here. Now, oh, that's interesting. It sleeps for a quarter second after. Probably just takes it some time to do. I could see the case to be made that we should add a property called high resolution, and when you set that property to true, it sets it to high res mode, and when you set it to false, it sets it to low res mode. That way, this part of the API stays the same? Or is it better to just have people use the new way, which is theoretically also better because if there was ever a third possible mode, then obviously the Boolean is not going to work. If there's above below output bit, then the hysteresis would show how far above or below. Oh, okay. Class had to put out the toggle. Looks like sample averaging. Does it fast enough? Is it if it does fast enough, it could throw out erroneous samples? Bias adjusting only needed due to the board heating normally. Unnecessary below 50C. DC? It's pretty hot, is it? Some sensors have compensation registers. Unsure if it has one. Got to work on some projects with my brother now. Have a great weekend, everyone. Yeah, take it easy, DJ Devin. Thanks for hanging out for a bit. Hope you have a nice weekend as well. Okay, so for sure, we either want to definitely change the simple test or else make a property that makes this API the same as it used to be. Because right now the simple test is definitely confusing in that it makes you think this will do something when it won't actually. Resolution mode. High resolution, this is the way to do it. The new library. Of course, I just modified this. Well, that's fine. We're going to want to commit it anyway, but Nice. Okay. BRB. I'll be back in a minute. Oh dear. Okay. Okay. How old is the library? Is it like brand new? Is it like years and years old? I don't have any sense. Last year, 3 years, 5 years. It's pretty old. Okay. Box failing? So that would need to change here as well. Potentially in the Learn Guide. So it won't need to change here because this one is linking directly to GitHub to the simple test file. If we change it in the simple test file, then it will be different here. But this one right here, we would need to change. Which has a screenshot actually also, which has the old code in it too, which we would need to change. I might be inclined to make this a copy paste instead of a screenshot because then it can be kind of altered without needing to reshoot. Okay. I think that kind of painful switching from Python to C++. Lost count on all the times I forgot to add the semicolon character today. Nice. I have been working in Kotlin lately, which is new for me. I've been trying to learn and work in Kotlin. And one thing I'm finding is compared to Java, which is what I am used to, Kotlin feels much more like Python in a lot of ways, and I keep trying to use Python comments. I keep trying to use hashtag for comments. And I think a lot of it is actually the semicolon in a lot of ways. Like the semicolon helps my brain switch between Java and Python, and not using it for Kotlin makes me want to use hashtag for comments. How much else of the API changed? There's only a simple test is the only code Boy, you know what we need to do though is we need to check learn for any other code that uses high temperature or whatever. Not high temperature, but high resolution. I think that I'm leaning towards making the property to bring in the old API. I'm not 100% though. Can I update? Why did it go so fast? Sometimes my updates are slow. Not too bad. There's one. So PyPortal, Adafruit.io logger. Maybe I should have searched on this. I mean, you can't be guaranteed it would be call ADT, but it probably will since it's mostly copy pasted, I think. But high resolution there. So PyPortal MQTT. What are the other APIs? Temperature? Anything else? Temperature. TT control. Okay, that's another one. Also just temperature again. So maybe oh, this is a temperature sensor on the PyPortal? Get temperature. It's in a different file. Oh, the temperature's right there. The source that okay. It's just not called ADT anymore. Okay, so that's another one that's the same. It would need to be changed. And this is the last one. Adafruit.io ADT. Does, yeah, need to be changed. Temperature. Only other API used. Okay. So nothing, what I was looking for is, does anything else, does any other code that we have in Learn currently use any of these, basically? Like, I was trying to find out, is this the only thing which used to be part of the API and no longer is, that has been used? And that looks to be the case, right? There's other things, right? Like this thing, this thing, this thing, this thing, that thing, that thing. Like there's other things that could have been used, but none of the code that is actually out there in Learn or the existing examples did use it. So like people might have projects that do. If we break it, they have to update them. For Learn Guide and the existing examples though, if we just made a property for high resolution, and none of the rest of these, then the old code will work. We could leave the simple test if we wanted. All the Learn Guide code would continue to work without touching any of it. I think that's the way to go. I think that's what's easiest, right? In some cases, I would say just change all the old code, which we could do. Like we could go to the Learn Guide and make a PR to change all of these to use the new way. We could update the simple test to use the new way. And the other example does actually technically use the new way. But it's inside of a for loop, which I guess makes it a little bit difficult maybe to tell if you're not used to it, what the code would actually look like to do it directly by itself. Yeah. Okay. Let's run the new examples, and then, well, let's work on this, I guess, actually. Let's try to change this with our property. So, like, what I'm thinking is, so we have, where's okay, so we have resolution mode right here. We have resolution mode setter. So then right, whatever, right here we have property, def high resolution, new value. No, that's on the setter. Return self resolution mode equals high resolution. So if we are on high resolution, return true, else return false. We do only have 2 right now. I was talking about if we added a third, some things would break. This would be one of them. Setter, no, what is it? High resolution setter? Def high resolution new val. Unit colon. We don't want to return. We want to set. Should be a boolean. Also, that's gonna return a boolean. Just set bool, right? Boo. Okay. Val. So we want to set it. So if it's true, if new val, we want to go self.resolution mode equals high resolution, else self.resolution mode equals low resolution. Terminal. There we go. Okay, so we are in. It doesn't seem like it worked though. High resolution. True. We're definitely still stuck on the 5s. We're in the VR version. Spell it wrong? Maybe we weren't on the latest version of the code yet, I guess. Okay. Let's do something like this. Grab part of that word simple test. It's kind of beyond what we need, but kind of curious. Import. Need to do this differently because we want to pull faster so that we can read the button. So let's get now, let's say if now is less than last print time plus print delay, then print, get rid of this, and last print time equals now. How do we have a last blink time? That's in a different, oh, okay. If button value, let's just go pass. Okay. If last print time, last print time equals 0, print delay, print delay. We're on half a second, what we started on, so let's keep it. Really, nobody's motion sick, sorry. Okay, if it's after, no, if now is less than last time plus the delay, then print the temperature. If I want debouncing also, but I don't want to use bouncer library last btn val. So I guess it's pull up, so let's do true. This button val is true. So if it is true and no, if not button val and last button val is true, then print rest. Is that the right debouncing? Okay, first of all, the printing is also broken, so now is less than, so that's going to be wrong. Is it greater than? Greater than. I always mess that up. I don't always mess it up, but I mess it up more times than I should, probably. Okay, have printing. Push the button. It should say pressed. Oh, but ideally it should not spam. But that's because we're not setting last button press val. Last button val, rather. So we need to say actually last button val equals cur button val. That's really what we should do. cur button val. This is better to put this in a variable and then reference the variable inside of this if statement and then also reference the variable down here instead of just using button val like this both here and here. It's better to do it this way because if you use button value both here and here, it means you're calling it twice, which means you're reading the state of the pin twice, which means it could change in between. So it could have been one value here and then a different value here, and that's going to mess up your logic on the next iteration. Whereas this way, we only check the actual state of the pin once, we do our own logic based on that, and then we set it as the previous value so that next time around when we compare again, we're going to be comparing to whatever we acted upon last time, not whatever value it happened to be if it changed in between. Hopefully we get pressed to be only print once and not spam now. Yeah. If I release and press again, then it goes again. Okay. And then so what I want is when you press the button, let's switch to the other value. So let's say when you press the button, we want ADT.HighResolution equals not ADT.HighResolution. So that should mean the button is gonna toggle us between high and low resolution. But the indention's broken. What is going on there? Is this wrong? Okay. I accidentally just did Control S. I'm pretty sure that breaks my terminal sometimes. Maybe it's Control Q. If I press a button, go to low resolution mode, but it seems like it's still the same. I don't know. Maybe you can't switch it live like that. Seems like it doesn't really like that very much. Does have that sleep. Where was that sleep? That's sleep. Operation mode. We're not actually doing operation mode, we're doing resolution mode. I wonder why it does this and if we might need it though. Okay, let's also just print ADT.HighResolution. Let's make sure that's toggling. Okay, pressed and then it changed to false. But we do seem to still have the high resolution data. But press, this goes false still. Okay, it always says false. Okay, so why would it always be false? I don't know. I'm wondering if we need this. 0.24 is such a length of time as well. That doesn't make a difference. Oh. This is returning strings. Not the constants. So this would be wait, what? Right. Okay. So yeah. Inside of here we want equals the string high resolution, not the constant high resolution. And yeah, then you set it's going to be the end. In my mind, I think it's best if the getter, the property getter, whatever it returns, I think, should be allowed to be passed back to the property setter. But right now, the getter returns a string. Hey, buddy, come here. Hold on, I gotta go wrangle the cat. So I would, like in my mind, I would probably opt for, I think, maybe the getter should actually just return the constants. Even though the constants aren't kind of like print out friendly necessarily. Or vice versa. The other option would be to have the setter take the strings, but I lean more towards the constants myself, but I see the upside of both, and honestly, I don't necessarily think one is inherently better or worse than the others. I just tend to lean more towards the constants myself. I've been forgetting to add the curlies. Okay, that should fix it though. I don't think I restarted. There we go. Okay. I think those are basically my only two real pieces of feedback. Is I think we should go ahead and implement that property so that the code is backwards compatible. And I think these two, well, I guess all of these things behave this way though, right? This is returning a string, but then this one is taking the what if we just make the setters take strings too? Okay. Yeah, this is basically the same for all of these ones. The return, so because like that's, well, that's the one we were looking at, but there's another one. This one has strings. It's going to return the string representing the value, and then that one's going to be wanting you to set to an int. Hey. Hey, hey, hey! Patty beans. Gotta play cat referee. It's my will, unfortunately. Not really referee, more so please stop fighting. Person. Don't.
No, this way.
Camera just died. Pop down camera. Is that a line? That's weird. Wait, really gonna be there? Probably not gonna be there. Okay. I think I should note also if we don't make this change, we don't make this change, we don't adopt this change, then we will need to change the simple test script as well as existing code in the learn guide for the product and a handful of other learn projects that use this sensor. But I think we should change it, but we don't have to change the code. Cool. We're done with this. I've somehow like zoomed this to be too big now. It's down. Okay. I will be back in a minute again. Gotta run to the restroom again. Okay. What do we want to do? Want to keep going? Work on something else? It's very old. Particular preview window. That's weird. Oh, it just suddenly updated itself. Oh no, it's not. It's just like playing from the beginning. Weird. Okay. Anyway, I guess we could keep going for a little bit more. Find something else. I think the next thing I would want to work on is Blinka display. Yeah. Let's see how big of a rabbit hole that turns into, if at all. Blinka display IO GitHub. This one, we want Adafruit one though. Fruit. Okay, so for folks that don't know, Blinka, Adafruit Blinka, the Python library is a compatibility layer that intends to make it so that you can run CircuitPython code, like code that's written for CircuitPython, so that you can run that on MicroPython microcontrollers, microcontrollers that are running MicroPython instead of CircuitPython, and also, and more importantly to the case that I'm looking at, on Raspberry Pis, on full Linux computers that happen to also have exposed I/O pins, many of which are quote-unquote single-board computers like Raspberry Pis and similar types of devices. There are lots of them out there. So that is Adafruit Blinka. Adafruit Blinka I/O then, or I should say Adafruit Blinka Display I/O, is the Display I/O core module, but implemented in such a way that it can be used in Adafruit Blinka. So on those MicroPython microcontrollers or on those Raspberry Pis running Linux. There was recently new versions of Adafruit Blinka, including the first major release to 1.0, which I think had a couple of breaking changes, lots of rewritten code to match the current Display I/O. And then there have been a few other changes in the interim as well. And my particular interest today lies with the Blinka Display I/O Pygame. I just saw it there. Where did all that stuff go? Why did all that stuff go away? Huh. I just saw it Display I/O. I don't know why that stuff went away. Hmm. Okay. So we talked about Blinka, we talked about Blinka Display I/O. This Blinka Display I/O Pygame display, this is a thing that I made that is made to work with Blinka Display I/O, and its goal is to allow you to run on a PC, a Linux PC or a Mac or a Windows PC, or a Raspberry Pi, which is also a Linux PC, and output onto the screen of the PC, output a window using Pygame. For those that aren't familiar, Pygame is like a Python game framework that can display windows and put graphics inside of them, do all kinds of other game-related stuff. In our case, we're having it spawn a window, and then we're drawing to it as though it were a display, a Display I/O display in CircuitPython. And in particular, we want to know, does it work with the latest versions of Blinka Display I/O? And if not, what do we need to change to make it work? And that's mostly it, really. It's not going to be in here anytime recent, so let's just open one, and then we do open. Let me also open the Pygame display. Okay, so right now, super basic, simple test, close others, run this. Okay, makes the kind of standard, if you've ever done Display I/O with a new display or with the basic simple test for lots of display drivers, you'll recognize this hello world with its purple and green stuff. Right, and then we're also cycling through colors in this case, which is a bit of a new touch that's not in most of the other ones of these, but It's kind of cool. Rainbows are fun, I guess. So that is working fine. What version do we have right now of Blinka Display IO? Pip show Adafruit Blinka Display IO. I don't know if that's the right way to do that. That seems like it worked though. 0.10.5. So that is quite old. Let's go pip 0.10.5. We can remember that. If we need to like try to revert back to it, we could go back to that one or something. Hopefully we won't need to revert back to it. Instead, hopefully it'll just work, or we'll start making changes to make it work. Pip install let me just do this, and then install like this, and then upgrade this. You mean install? I do. Okay, 1.1.0. So now let's run this again. No. Got our warning. That is it. Okay. Let's see. So this did not fail, which is interesting. Did we make it to here? Print after made display? No. We never finish making the display. Why would we never finish? So that is in display extends display. Inside of init says do some things like set this variable, this thing, that thing, those things. Empty, 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 false. Reading event. If flags full screen or 0, 0. You don't have that. Super init none. Display bus. Init sequence with height. And then we overrode get screens. It's not override, I guess, but get screen size underscore initialize high game refresh write, which is wanting to write to the spy bus, which we're not using, so we have it but we don't use it. Release gets rid of the pygram thread stuff. Refresh, which is important because internal display should be calling refresh. Yeah, one thing is the threads are a bit weird now. Somebody fixed it to work. At one point I had to make it be non-threaded somehow, and then that broke it on Mac or something, and then somebody found a way to fix it. And the truth is I don't fully understand the way that it's been fixed, and so now we have code that is mine that I don't fully understand, but it's how it goes sometimes. I'm grateful that they fixed it for their environment. Check quit event loop, refresh display area, auto refresh root group. Somebody did the root group also. I don't remember who that was off the top of my head, but thank you to them too. I don't. So we are not making it outside of init. So I mean, I guess we start printing stuff here, but I mean, it's going to be this, right? Before super init, that one will get printed and this one won't. I mean, probably right. Huh. Is this the version of the library we're using? No. We need to pip uninstall it, I think, maybe, and that will make us use the one that's in this directory. Okay. Do I not seem to have any ability to see my printouts? Okay, plot thickens. I mean, surely. Maybe it fails on the import when it imports from display IO. Okay. Okay. Universe is like not totally broken. Okay. Then it's got to be this print before. Man, there's gonna be so many prints. Before import. That's good. Yeah, that's fine. Let's just do that. No, let's do Pygame display. Because I already have import up there. This will work. And then, but if I did an after, it will fail. And if we chase that, it will be when we import from Blinky Display IO, probably, right? I don't know why I'm so confident. I guessed a bunch of times I've been wrong already, but it's cool. We're getting closer, right? Probably. And again. Okay. Display IO, probably, right? Print before import display IO, after import display IO. In a minute. Oh. That one finally did more stuff. Never did get a window, but... Huh. Did I just not wait long enough? I mean, that was like a lot of seconds of time. Did make it past that import, so that's not the spot we are stuck inside of. We stuck. And do we actually just... It has to be these are the last two, right? They're Pygame or PL. Are we actually just stuck? Why would we be after import Pygame? Does eventually go, actually, yeah. After import PIL? And this failed back to what now? This says we got all this stuff, and then we failed back to creating the display. But somehow we failed in such a way. Oh, I don't know. We need to run again, right? We need to run again. I mean, it must be inside of here, but why would that have changed at all? That doesn't make any sense. Import display L. Pygame. We didn't change Pygame. Since here a 10.5 I had doesn't actually exist. I mean, we didn't have the same super long. We didn't get to it though, because we failed sooner. Something else. Okay. um. So. Somehow using the newer version of Blinka Display IO makes it so that we get stuck during the Pygame import for longer. Quite odd. New, can we push it? It still work. Guessing this is where it's. That's what we get. It's the same thing. Pygame takes longer. That's very weird, though. I mean, it can't be really that, can it? So this will go chase down and solve. Eventually we'll need to do that to make this stop crashing, but I don't think this, I didn't take that long, and I don't, that's our first thing to solve, I think. Even though I guess it does get past it and doesn't crash. Get how the version of Look at how the version of display IO could impact the amount of time that it takes to import Pygame. Yeah. In thread functions to loop through all displays and update them. So threading is probably involved in this. Certainly when time feels manipulated, strange ways like this, threading can definitely be. What's going on here? Release displays, loops over displays. Allocate display. Allocate display bus. Background thread, threading thread. I wonder if we're like somehow double background threading, but then why on the import though? That's so weird. Right, background daemon true, start background thread. Background thread. So that's definitely new. That's when we import display IO, we now have this kind of threading thing going on. Area is going to be a helper for a rectangle, probably. So affects anything we're doing. Bitmap. Bitmap. I import Pygame first. I change the order and we just don't have this problem. That seems pretty convenient. It's so weird though. I don't get. Oh, okay. I kind of didn't think that was gonna work to let me out of it. Okay. I mean, sure. I don't really care. I don't think. I mean, Pylint cares about the import order more than I do. I will happily tell Pylint and stop caring if given the chance. For threading. But now we're not using any of the new. We'll get stuck when we run this way. That's pretty weird. Their new Pi game. I don't even really know where to begin. And it's, I guess if it works after those several seconds, it's not the end of the world. In a way, it's kind of unusable. Makes me not want to work on it for one thing if I have to iterate waiting that long. Get lucky and there's some fix there. It's so weird that display IO version would ever affect it, even when we haven't imported it yet, which and it's like right away done, no problem. Nothing else. Let's see. Okay. Okay. Because IO is part of Display text. Our game is the first thing we import. We have not touched anything. Just goes fast. Okay, it's a victory, but it doesn't really feel like it. The next problem is a bare none type has no length. Init sequence. Okay, it's mad because I used a none. It's mad because I cheated a none for a init sequence. But the thing is, like, this Pygame display thing is using Blinka display IO in a way that wasn't intended to be used, basically, originally. Because Blinka display IO itself is kind of assuming there's like a SPI bus, and we're going to interact with it and stuff to send data to display. But in our case, there's not. We're not using a SPI bus. Therefore, we don't have an init sequence because we're not initializing the display over the SPI bus. Display 167. While length of I is less than, no, while I is less than the length of the init sequence. So do I give it a empty list maybe? I don't know, what's the init sequence normally? What's the init sequence for like anything really? No examples. I don't know a good place to find examples. Oh, we don't get to see it. Its sequence, I guess, is like inside of this. The tuple of strings, byte strings. But we could either be maybe an empty tuple or an empty list. Maybe it'll work. Instead of like my first thought was I could just go add a check that says if it's not none, then do this. But like, we could potentially fix it without touching the Blinka display IO code too. So init sequence instead of none. What if we just do tuple? Empty tuple. Has no attribute auto refresh. I don't know. Did I? Maybe I did. Auto. That's enter. A refresh. Game display. Auto. Okay. Well, made it slightly farther. We found out whether or not it works. The answer is it doesn't, and there's some weird delay with importing it, but we've managed to get past that, at least until we run Pylint, and I presume it complains about the order of our imports. We either tell it to ignore or find some other way to fix it, taking a very long time to import, which seems like a hard thing to troubleshoot to me. Kind of surprised we managed to fix it just by changing the order, even though we had to chase it a bit further and make sure that we were also not importing from higher levels anything from display IO yet. Next thing is something to do with auto refresh here. I'm not exactly sure what it's referencing. Don't. Oh. Okay, maybe maybe there did not used to be. So I think maybe this next problem is potentially there did not used to be an underscore auto refresh on display object, and now there is. But why did we not see that here? This is folded. I wish it would not do. Is auto refresh is new. Yeah, see, that's green. Guess there is that though. Display. I mean, we used to have it like this. Where's the new one that I saw? Where's this? Oh, this is inside display. Scroll past it. Okay, it used to be down here in this big list, now it's up here. So we did still have it though. I mean, at least as of, well, yeah, this is the 1.0 changes, which is where it stopped working. Okay, so my theory was maybe the old one did not have self._auto refresh and the new one did, but then also the Pygame display did. And then like Pygame display was trampling on the now existing concept of _auto refresh display inside of its parent class. But that's not the case. That seems to have existed before. Seems to have existed before, and I'm not entirely sure. After made display. One thing I find strange is none of this backtrace goes to our file. Let's print. We made it all the way to here. That's what this is. Then it just says exception in thread background threading. Display._background. And display._background says if auto refresh. I don't know. That's weird. But I think I'm going to call it for now. Thanks for hanging out. Thanks for watching along. Hope everybody has a good rest of your day, good rest of your weekend, all of that kind of stuff. I will be back for the deep dive, like I mentioned at the top of the program. Thankfully, I remembered. I'll be back for the deep dive on Friday at it's 4 p.m. my time, which is central, but it's usually billed as 2 p.m. Is that right? 2 p.m. Pacific? Yeah, 2 p.m. Pacific or 5 p.m. Eastern. That one will be over on the Adafruit channel instead of here. I should also be back on. I should be back on Saturday as well next week. So back in the same time, 10 a.m. Central here on my channel. So I'll be back then for some coffee and some CircuitPython coding as well. But Friday for deep dive, we'll hang out some too. I think that's it for now. Enjoy the day. I will see you all later. Thanks.